Hello, Assalamualaikum dan salam sejahtera everyone. Today our group will present about our signal conditioning, which is our system temperature monitoring system in a nuclear reactor. So signal conditioning. So there is two pictures that shows what is signal conditioning is. So signal conditioning is the part of data execution system that interfaces a sensor. Most sensors require some type of accommodation to turn their input into a linear voltage that can be measured by a data execution computer. Often the signal is too small and must be changed to a form that can be read by the computer, or the sensor needs power. The process is called signal conditioning. So, signal conditioning includes the amplification, filtering, converting excitation, and other techniques required to make sensors output compatible with the data execution hardware. The proper design of the signal conditioning module is critical for maximizing the accuracy of the DAQ system. So, common techniques to condition the input signal include amplification, linearization, filtering, isolation, simultaneous sampling, excitation, cold junction compensation. So this is the pictures of this is the example of signal conditioning circuit for RTD transducer. Filtering is Filtering can be made from either passive or active component or digital algorithm. A passive filter only uses capacitor, resistor, and inductors with a maximum gain of 1. An active filter uses passive component in addition to active components such as operational amplifiers and transistor. State-of-the-art signal conditioner use digital filter because they are easy to adjust and no hardware to require. Amplifying. There are two ways the signal amplification can be performed: by increasing the resolution of the input signal or by increasing the signal to noise ratio signal. The conditioning use a range of different amplifiers for different purposes, including instrumentation amplifier, which are optimized for use with DC signal and are characterized by high input impedance, high common mode, rejection ratio (CMRR), and high gain. While linearization, certain signal conditioners can perform linearization when the signal produced by a sensor do not have a straight line relationship with the physical measurement. This is the process of interpreting the signal from the software, and it's common for thermocouple signal. So these are some explanation of common techniques of signal conditioning. So the resistant temperature detector, or RTD, is a sensor whose resistance changes with temperature. RTD is the passive sensor that required current excitation to produce output voltage. Caution must be exercised using current excitation because the current through the RTD causes heating. This self-heating changes the temperature of the RTD and appears as a measurement error. Hence, careful attention must be paid to the design of the signal conditioning circuitry so that self-heating is kept below 0.5 degrees Celsius. Manufacturers specify self-heating errors for various RTD values and size in still and in moving air to reduce the error due to the self-heating. The minimum current should be used for the required system resolution, and the largest RTD value chosen that result in acceptable response time. Another effect that will cause measurement error is voltage drop in RTD lead wires. This is especially critical with low value 2-wire RTDs because the TC and the absolute value of RTD resistance are both small. If the RTD is located at a long distance from the signal conditioning circuitry, then the lead resistance can be ohms or 10 of ohms, and a small amount of lead resistance can contribute a significant error to the temperature measurement. So that's all from me. Next, my friend will explain you guys.
Good day to everyone. Name is Ravinesh. So I'm going to explain the part of identifying the problem in our temperature monitoring system in the nuclear reactor. Okay. First of all, there are two problems which I have enlisted here. Okay, the first one is small output from the RTD. Okay, as we know that in the RTD circuit we have 4 resistors due to the full bridge whetstone. So each resistor has higher resistive values which leads to the output voltage which we can obtain in only millivolt. So the highest could be 30 millivolt. So this, taking this to account, we have to find a solution to magnify the voltage so that we will get less error during our translation of voltage output from temperature, from voltage output to the temperature. And one more thing is we cannot increase the current flow in the circuit of our RTD due to the self-heating problem we have in our RTD. So the current flow in our circuit should be very less in minimum amount in order to get accurate reading, and we don't want the reading from the self-heating of our RTD. Thus we have to have a separate circuit in order to magnify the voltage output to get clearer output results, the last output result, which is the temperature. Okay. Second is noise. So noise is a common problem in RTD circuits because their cables tend to attract signals from the surrounding. In case the noise could come from surrounding where there are many systems working around our RTD. So if you take into account our nuclear reactor system is a massive system where there will be a lot of instrumentation circuits and other circuits as well. So if we want a clearer error, a less error output, we have to do some filtering processes in order to cancel out noise coming from the surrounding. So this should be solved in order to get very less error output temperature. That's the main problem we have to overcome by signal conditioning for the temperature monitoring system. Thank you.
Good day to my lecturer and my dear friends. I am Kavin and I am going to present about the suitable signal conditioning method to solve the problem in a nuclear reactor, to measure the temperature of the nuclear reactor. So the first signal conditioning method will be filtering. Since we are using a RTD to measure the temperature of a nuclear reactor, too much of background noise could be a problem in our system. The first line defense against noise pickup is a proper cabling. RTD wires should be connected through shielded cable containing a twisted pair for RTD element wires. If the noise is still needed to be reduced even after the cabling, the signal condition is significant. In many applications, RTD sensor placed near the application and remotely away from the analog to digital converter. The suitable signal conditioning method for the problem stated above is filtering. RTD sensor is placed remotely and can be prone to noise pickup. Input resistor capacitor, anti-aliasing low pass filter frequently are employed to improve the end product immunity to radio frequency interference. For effective radiometric cancellation to occur, the errors due to drift and noise of the excitation source must be equally reflected at the ADC. Therefore, it is important to ensure that the input filter and the reference filter have matched time constants or the cancellation of current source noise. External filters may be required to eliminate the noise interference. Designers should exercise special attention to balance the corner frequency of the input low pass filter and the corner frequency of the reference low pass filter. The RC low pass filter consists of two matched series resistors, one differential capacitor and two common mode capacitors. The figure shown beside is the typical RC low pass commonly used at the inputs of a differential amplifier. This filter provides attenuation to both differential and common mode noise signals. So the figure shown in this slide is about the simplified RC circuit and can be used to estimate the corner frequency of the differential and common mode input filters. In detail, RC low pass filters can be applied at the input and reference path of the ADC in the radiometric configuration. Matching the filters at the input path and the reference path results in better radiometric cancellation. The excitation signal source is set to 0 by replacing the current excitation source with an open circuit. We replace the differential input capacitor with a test voltage source and the rest of the capacitors with open circuits. So since we are gone through with the first signal conditioning method, the second signal conditioning method will be amplification and the process of increasing the signal for processing or digitalization. There are two ways that signal amplification can be performed: by increasing the resolution of the input signal or by increasing the signal to noise ratio. Signal conditioning uses a range of different amplifiers for different purposes, including instrumentation amplifiers, which are optimized for use of DC signals. Those are characterized by high input impedance, high common mode rejection ratio, and high gain. Another example of a signal conditioner used for amplification would be an isolation amplifier, which is designed to isolate high DC levels from the device while passing small AC or differential signal. And that's all for my presentation on suitable signal conditioning method to solve the temperature measuring problem in a nuclear reactor, and the further details will be explained by my friends. Thank you.
RTDs are generally configured in a 4-resistor bridge circuit. The bridge output is amplified by an instrumentation amplifier for further processing. High resolution measurement analog to digital converter ADC, such as the AD70, allows the RTD output to be digitized directly. The figure shows a 100 ohm platinum RTD driven with a 400 ampere excitation current source. The output is digitized by the ADT70 series ADC. The RTD excitation current source also generates the 2.5 volt reference voltage for the ADC via the 6.25 kilo ohm resistor. The ADT70 is a complete platinum RTD signal conditioner which provides an output voltage of 5 mV per degree Celsius when using a 1 kilo ohm RTD. The platinum RTD and the 1 kilo ohm reference resistor are both matched with a 1 milliampere matched current source. The ADT70 contains two matched current sources, an instrumentation amplifier and a 2.5 volt reference and an uncommitted rail-to-rail output (OAMP). This allows temperature measurement to be made over a range of approximately -50 degrees Celsius to 800 degrees Celsius.
A very good day to everybody. I am Tanusha and I will be continuing from here with the expected results. So, as how my friend explained earlier, we use signal conditioning to alter the errors we get by either amplifying signals into an easy to read and compatible form for data acquisition or by filtering. So, the problem we stated was small output from the RTD and the second problem being noise. So, moving on to the first problem. First problem, which is small output from the RTD, is due to high resistance. As explained, this will need signal amplification and the process of increasing the signal for processing and digitization. So undergoing this process will amplify the output voltage by the RTD, which will lead to accuracy in translating to temperature as final output. I repeat again. Undergoing this process will amplify the output voltage by the RTD, which will in turn lead to accuracy in translating to temperature as final output. So now moving on to the second problem. So the second problem being noise. So this happens due to the vulnerability of the RTD in the cables and too much of background noises. Unwanted noise can occur, which in turn will mislead the temperature measurement. So this is what we don't want and we want to fix it. So as this could give significant error in translating the voltage output into temperature, unwanted noise has to be filtered. So as already explained, this process will need filtering. So external filters is required to eliminate these noises. So undergoing this process will filter out the unwanted noise to be able to provide output without any errors and accuracies which is damaged by the unwanted noise. So all signal conditioning process are crucial to obtain maximum accuracy, and we have to amplify these small resistances and we have to filter out these unwanted noises in order to get a better result. That is all from me. Thank you.